Hi folks, we're going to do some problems from chapter 11 on fluids, density, and pressure. Here goes. Sheldon finds a small piece of metal. He measures its mass to be 7.41 grams and its volume to be 0.656 cubic centimeters. What is the density of the metal? This is a simple little density equation. We want to know density. We know mass is 0.656 cubic centimeters, and the volume, boy did I make that boo-boo up already. That is the volume, and the mass is 7.41 grams. Now we are working in this problem in the CGS units, grams and centimeters. This is the set of units that is much more common in chemistry than is used in physics, but they work just as well. So as you know, density, in other classes, you may have used density. Physics, we tend to use Greek letter rho for density. Density is mass divided by volume. So density is going to be the mass, 7.41 grams, divided by the volume, 0.656 cubic centimeters. So when you do the math is going to be 11.3 grams per cubic centimeter. Now the question is, what is the identity of the metal? If you then take this piece of information and you look on the density chart, I've given you a sheet of common physics constants, and one of those charts is a list of densities. I want you to look that up and see if you can determine what element that is. And there is one element from the periodic table that has a density. It's even on that density chart because that limits it down to about a dozen elements. And see if you can figure out what that is. I'm not going to tell you. You can do that one on your own. Okay, problem 2. What's the volume of a piece of gold with a mass of 22.2 grams? So volume is the question mark. Mass is 22.2 grams. And this problem looks like you don't have enough information. You have to look on a density chart because density is one of those physical properties of a material, of a pure substance that is very consistent. So density of gold, elemental gold, is 19.3 grams per cubic centimeter. Density is mass per unit volume. If we want to get volume alone, we're going to multiply both sides by V, and then to get volume alone, we're going to have to divide both sides by density, and that's going to convert the equation into volume is mass divided by density. So volume is going to be the 22.2 grams divided by 19.3 grams per cubic centimeter. Our grams on top, grams on the bottom are going to cancel. We're left with cubic centimeters, but they're down in the subbasement. So how the heck is that going to work? Well, we do the math. We're going to end up with 1.15. We take it out to 3 sig figs. Should be cubic centimeters. Let's take a look at where those units come from. Grams divided by grams per cubic centimeter. So invert and multiply. Cubic centimeters over grams. These two are going to cancel. Cubic centimeters, that is a happy unit world. Next problem. Isaac is a curious young lad. He wants to know the weight of the air in his bedroom. His bedroom is 8 feet tall, 12 feet wide, and 14 feet long. How much does the air in his bedroom weigh in pounds? Okay, all right, this one gets a little bit tricky. Well, if you have a rectangle of any sort, a room, a Kleenex box, whatever, you know that you can find the volume of a rectangle by going length times width times height. So we're going to begin by doing that. So this is going to be 12 feet by 14 feet by 8 feet. And when we do that, 12 by 14 by 8, I got 12 by 14 by 8. I have 1344 cubic feet. And I apologize, when I wrote this problem, I did not give us enough sig figs to work with. So let's say we have 3 sig figs. That is a merry problem, so I apologize. So let's round this off to 1340 feet cubed. Okay. Now, I want to know how much does the air in his bedroom weigh. We know density is mass divided by volume. We can find the mass if we take the volume we've just found, multiplied by the density. Now, if I go looking out into yonder interweb and try and figure out where the heck the density of air is, and it's also on that constant sheet that I gave you, the density of air can be found to be 0.001293 kilograms per cubic meter. That's spiffy, and we can certainly use that, but in order to use that number in this equation here, we have to get volume in cubic meters. So remember all that unit converting we did long ago and early in the class? Yep, you get to haul it out and show it off. So 1340 feet cubed, and we're going to get rid of feet, keep meters. There's 0.305 meters in a foot. That's going, and feet cubed means there's 1, 2, 3 of them. Feet times feet times feet. This is going to get rid of 1. How do I get rid of the others? Do it again. 0.305 meters in 1 foot and 0.305 meters in 1 foot. And I know some of you are going, you can just cube the fraction. Yeah, I know you can. You do whatever works for you, but this one is the most stupid proof. If if you're having a day when you haven't had enough caffeine, do it this way. Okay, and I'm going to do the math, and when I do this, I end up with 38.0 cubic meters. 38.0 cubic meters. So the mass of the air in his bedroom is going to be volume times density, 38.0 meters cubed times the density, 0.001293 kilograms per cubic meter. Cubic meters are going to cancel, and that is going to end up being, so I've got 38 times 0.001293. I end up with a mass of, that's not a lot of mass, 0.0492. That's 492 kilograms. Okay, are we done? Well, let's look at the problem. What's it say? How much does it weigh in pounds? We want to know weight in pounds. So you can look on your conversion sheet, and if you look on your conversion sheet, it says there are 2.2 pounds in a kilogram. It's a little bit cheating, but it'll work. We'll take that. 0.492 kilograms. We got to do a mathematical conversion. Get rid of kilograms, go to pounds. There are 2.20 pounds per kilo times 2.2, and I end up with 0.108 pounds of air. Are you surprised that that's a little or a lot? All right, that will do for the first 3 problems, and we'll see you later. Bye.